Hello and welcome back to the lecture of time series econometrics. In this lecture, we are going to talk about forecasting. Now, that's very important for us because the time series that we build and all the tools that we have learned so far, basically, there is a practical purpose for it. And the practical purpose, one practical purpose is to kind of forecast the time series. And that is being used in business, in economics, in politics, and in many, many spheres. Wherever you use basically time series data, you do forecasting. So there are certain tools of forecasting that we use, and in this lecture we're going to talk about that. So in this first lecture we are basically going to talk about a very simple forecasting tool which is known as simple moving average. Now in simple moving average, what we do is it's sort of a smoothing technique, and what we do here is we basically do not really use the parameters or the model identified model or the specification that we have got in the time series analysis part. But what we do here is we simply take the average of past period values and we can write it as a moving average. So let me write down simple moving average. So in this simple moving average technique, how we write it is moving average of period M is equal to, say, I equal to 1 to M, and say y t plus, say, I. Okay, so you basically take the moving average for M periods, simple moving average. Here we need to understand one simple concept, and that is known as window. So window here is the time period that I take. Here M is my window. So how many time period I'm taking is known as window. Now there are two types of windows. One is the uh, centered window, and other is a trailing window. Centered window and a trailing window. So in centered window, how we do is, suppose this is my time period t, so the window I will take is basically on the both side. Okay, so t is in the middle, whereas in case of trailing window, if this is my time period t, I'll actually take all the time previous to time period t. So there are usage of centered window, and uh, trailing window. In case of forecasting, which you're basically going to see, we use this one, which is the trailing window. But centered window is used when we are, sort of doing the visualization of time series and many other occasions. You can specify in your R code whether you want a centered window or a trailing window. Okay, so that's basically the concept is this. Now, this moving average technique is, we are familiar with it. It is used for both time series analysis as well as for time series forecasting. So here now we are going to see particularly the forecasting part. Now how we do it? Well, so it basically takes the value of past period. So only thing you need to identify here is sort of the order or the time period, the window size, whichever you call, in your R code. So only variable that you can provide in your, or the parameter that you can provide, is the window size. Okay, and so depending on the window size, you will get different sort of smoothing. So you can make a guess. If you have the window size is large, say 10, like if you take a small window size, large window size. So if you take a large window size, it will be sort of more smooth, whereas a small window size, it will be more zigzags, right? um, One thing about this smoothing technique, we are going to see it when we actually do this smoothing. um, uh, we are going to actually see that forecast values the forecast values do not show a trend. Okay, so we actually lose the trend. Even if the data might have some trend, we will actually lose the trend. Also, it will actually, the seasonality will be smoothed. Okay, you will not see any seasonality when you are actually plotting a simple moving average forecast. Okay, so let us similarity will be smoothened. Okay, will be basically it will be vanished, will be smoothened. One more assumption about this simple moving average is that, let me write in a different color. It assumes the time series to be stationary. It assumes the time series to be stationary. Okay, so that's an assumption, and we can't really know if we're getting a better result or a worse result if the stationary condition is violated. So there are certain sort of vague areas when we are actually using this um, simple moving average. And as I said at the beginning, it really doesn't matter whether I have estimated the model or whether I have my parameters in my hand. It really doesn't matter that way. So you're simply going to take the values that is given to us, and you simply do the moving, take the average values. A couple of more things. So window size, suppose if we take a window size m is equal to say 1. Okay, so that is a list that you can take, so which means that you only take care of the past period value. So basically when you take the average of one period value, that means the value itself, right? So it is going to be extremely zigzag. So highest level of sort of zigzag that we can see, or the minimum smoothing that we can see by taking m equal to 1, and this is called under smoothing. Whereas if you take the whole length of the training period, right, whatever data is provided to you, if you take the whole length of the training period, say if I can write m is equal to m, or yeah, basically no problem, there's no problem, where m is the maximum window that is given to you, so then it will be called as over smoothing. Okay, the first one is under smoothing and the second one is over smoothing. All right, so now that we have done it, we will go to do the R code. But before that, let me say a couple of more points. So, in general, we would prefer M value to be not very it should not be very small, because then you will get a sort of not so good smoothing. So you would prefer somewhat a bit somewhat smoothing, like some smoothing which is not like either over smoothing or neither under smoothing, right? So you need to find out some optimum value of the order, and one way to get it is basically you calculate the error. Okay, so suppose you have a time series, say 1 2 3 4 5 6, and the values, say you get different values x y z a b c, and what you do, suppose you take a 2 period or 3 period, say forecast value. So if you take a 2 period value, so you will get corresponding to this x minus y by 2, then you will get for this one you will get y plus z by 2. Okay, something like that, and you will get error. So error is basically z minus x plus y by 2, right? Here a minus y plus z by 2, and so on, right? So then using this error you can calculate many different types of estimations. For example, mean square error, uh, mean adjusted deviation, and many other ways of mean absolute deviation. So there are different ways of calculating the error, and in R code we are, when you run the R program, you will see how the errors are actually going to play a role. We'll also use Akaike information criteria, Bayesian information criteria, and so on and so forth to kind of identify the right order of the model.